Good evening, and welcome to this evening's BTS meeting. Tonight, we are very pleased to hold the 2021 Harding Prize competition. The Harding Prize competition is named in honour of Sir Harold Harding, the founding chairman of the BTS, and is open to all young engineers aged 33 or under. This evening, we will be hearing presentations from our three finalists. Firstly, we will have Benjamin Lafarga, an assistant engineer from Mott MacDonald. Benjamin completed his MSc Civil Engineering Studies in the Polytechnical University of Valencia, Spain. In 2014, he joined the Mott MacDonald team in Prague as a junior tunnel engineer, and he participated in projects such as Baku Metropolitan, Hong Kong Central Kowloon Route, and Doha Metro Gold Line. In 2016, he joined Bula AG, where he was involved in the design of industrial buildings, basements, and shallow foundations. In 2018, he rejoined Mott MacDonald in the UK and has since worked on projects such as Tideway and HS2, covering SCL segmental cast in situ line tunnels and shafts. Benjamin has a special interest and focused in digital tools, structural and geotechnical analysis, and fibre reinforced concrete design. Tonight, Benjamin's paper is entitled HS2 Euston Station Ventilation and Substation Enabling Works, Implementation of Parametric Design in the Tunnelling Industry. Our second finalist this evening is Kate Anthony, a senior tunnel engineer from Dr. Sowers and Partners. Upon graduating, Kate joined the team at Tottenham Court Road Station Upgrade on her first tunnelling project as a shift engineer working for BAM Nuttall, which inspired a love of tunnelling. Since then, Kate has studied the MSc in Tunnelling and Underground Space at Warwick University before joining Dr. Sauer and Partners in 2013. In recent years, Kate worked in both the design and construction phases of Bank Station capacity upgrade before being seconded to Arup working on Crossrail 2 and HS2. Currently, she is working with the Dr. Sowers and Partners team at HS2 Euston Station. Tonight, Kate's paper is on Bank Station Upgrade, the design and construction of pile interception load transfer structures at 6 to 8 Princes Street. Our third finalist this evening is Christina Triggle, a section engineer from BAM Nuttall. Christina graduated from Imperial College London in 2018 with a first in MEng Civil Engineering. She has since been working for BAM Nuttall on shift at Thames Tideway West, where she started off on the SCL shunts before moving on to the TBM for its launch and entire 7-kilometre drive. She is currently a section engineer working on the short SCL tunnel to connect with the central section at Calmouth Road. Tonight, Christina's paper is on Thames Tideway, the impact of COVID-19 on TBM tunnelling for the Thames Tideway Tunnel. We will hear all three presentations this evening before the judging panel and members online can ask questions of all three finalists. So please add your questions to the YouTube chat, making it clear for which finalist they are for. The judges will then adjourn to make their decision on the winner of the 2021 prize, which we will announce this evening. During this time, whilst the judges adjourn, we have a special guest for you this evening, and something we are very excited to showcase to you all. So please hang on during that judging period. So now I would like to introduce our first finalist for this evening, Benjamin.
Okay. Good evening, everyone. I'm Benjamin Lafarga, and I'm a tunnel engineer in Mott MacDonald. First of all, I hope everyone is keeping well and safe, and also I'm really looking forward to meeting you in person again after such a long and difficult time. Today, I want to introduce my work in implementing the parametric design in the tunnel industry in a fee-earning detail design project for HS2 for the HS2 Euston Station enabling works. In this presentation, I will follow the same scheme I used in my paper. I will introduce the motivation of using digital tools in our design, and I will quickly explain what parametric modeling is. Following to that, I will explain the application of this new design methodology in our project. And to finish with this, I will explain I will show the lessons learned, the further steps, and the conclusions. There is a clear agreement within the sector which states that the efficiency in the way we deliver the project should improve. To face that challenge, Mount McDonald launched the campaign Go Digital, where digital tools play an important role. I have been involved in the development of a new design concept, taking into account these three main goals. First, we seek to speed up the design process so that any change can be quickly implemented. Also, a way to reduce the unproductive and abortive work associated with this iterative design. This is sometimes frustrating as something to be avoided. So actually we can make the most of our time. We wanted to keep the design in the engineering hands, owning the model, in order to increase the reliability and the quality of the final product. And finally, we want to create an auditable and trackable single source of truth, which I will explain later. I have been involved in the research of the appropriate digital tools available in the market. Parametric modeling, which is used, for example, in architecture, and mechanical design software, which is used in the manufacturing industry, were considered to have potential to be used in the tunneling design. Software such as Dynamo, Generative Components, Grasshopper, or Inventor were explored. With this short video, I want to show you what are the principles of parametric modeling. By means of a series of input parameters, we define the variables of the problem. And with the algorithm, the rules. With this, we can quickly modify the geometry by varying the parameters. So in this example, we can see how we can make the tunnel larger, thicker, or change the alignment. Parametric modeling is not a new concept, but the real challenge was to apply these principles and an automated design concept into a fee-earning project of this magnitude. There were several challenges in this project, such as interfaces with other parties or unknown data. To tackle this and to increase the efficiency in our design, parametric modeling came up to be a good solution to solve those issues. After our previous studies, we were confident that we could apply this into the high-speed 2 enabling works in the Houston station. Due to the characteristics of this and size of the project and the engagement of the client, it made ideal this option. And this is a detailed design project, which is currently in process for final approval from HS2, and the construction is expected to start this year. A quick overview of the project. There is an existing head house within the footprint of the new Houston station for HS2. So this existing head house, which belongs to London Underground, needs to be relocated outside the footprint. And this new head house needs to be connected by means of a series of tunnels to the existing underground infrastructure. In this conceptual sketch is shown the existing London Underground head house, which will be demolished, and the new head house here in the left. There's a temporary shaft that will be installed, will be built to allow the construction and the connection and the mine tunnel and the connection to the existing LU assets. This is where I will be focusing my presentation. Bear also in mind that in a further stage, there will be the base lab of the HS2 Houston station will be very close to the crown of these new tunnels. In this project, I was responsible to develop and implement the design methodology based in a fully automated geometry modeling. I have summarized the process in these 5 steps. Design the concept and parameterization sequence, coding, generating the 3D model, model validation, and model and drawing generation. Indeed, I like this slide, really, because even when designing a fully automated modeling system, defining the engineering concept remains absolutely the same. Then we need to define how the structure is going to build up in a logic manner, something similar of what you will be doing modeling manually a 3D geometry. The difference here is that instead of fixed dimensions, the parameters that define the geometry are variables. The next step is to generate the subroutines, which will be repeatedly used in our coding. In the left, for example, you can see the subroutine that gives as an output the 3-curve tunnel profile, taking as an input 6 parameters: radius, angle, and reference points. To code the assets in this project, I use the commercial software Autodesk Dynamo. This is an intuitive and user-friendly software which only require basic programming skills. Once the asset is coded, the geometry can be transferred to the building information modeling environment, as shown in this case for the temporary shaft and the tunnel connection and the adits. However, before importing it, I developed a full validation process in order to first validate the script that has been coded, and second, to validate the geometry itself coming out from the script. The input parameters are logged in a database, and this database is called automatically by the script. This input database was our single source of truth. With this system, I ensured that the whole model was always using the most updated data. For this specific project, for example, we've been using over 120 parameters, which were used within the 3 scripts that define the whole set of assets that we were designing. Finally, once the script and the geometry is being validated, the geometry could be imported into the BIM environment. And this being the base to produce the 2D drawings. I was, as a BIM manager, I was in charge of the drawing production, where over 60 detailed design drawings were submitted for this project, without counting the RC drawings. We also used parametric modeling to generate the geometry for the structural and numerical calculations. With this short demo, I want to show a real script and how it works. As an example, let's imagine that there has been a late design decision and we need to modify the shaft junction. By changing the required parameters in the input database, you can see here, we're changing the alignment and the radius of the tunnel. We can obtain our new geometry within seconds, as you can see here. Here I'm showing that how, thanks to parametric modeling, we can ensure our structural model to be aligned with the updated geometry. This provides consistency to the design process. Finally, I want to show the geometry exported in the BIM software and how flexible and convenient it is to explore the different geometries in this dome-shaped head wall. I would like to speak now about several specific examples of this project, which made parametric modeling extremely useful. At the beginning of this project, we suggested a number of significant changes, which would add value to the design and the future construction. So here you can see in the left, the preview concept, and in the right, our proposal. Parametric modeling gave us the agility needed to explore and adapt the new solution, increasing the quality of the final solution. Since we spent less time dealing with the geometry and instructing the CAD technician, we had more time to invest in other engineering issues. The interface with third parties were a challenge. All the parties were involved, and this was a highly constrained area and condensed area. And more importantly, the other packages and the interfaces were in other stages of development. So change could happen in a very late stage. As an example here, I show you our tunnels and the temporary shaft. And this is within an array of piles, and above the piles will be placed the base slab of the HS2 user station. So an example with this, for example, was that the loads coming from the base slab changed in a very late stage of our detailed design, which led to certain modifications in the model. Thanks to parametric modeling, we were able to update our geometry pretty quick. And also, we were able to deal with what we call known unknowns. Okay, so the main purpose of this project was to connect the new tunnel here with the existing London Underground infrastructure right here. However, by the time we were designing, the exact dimension and location of the existing assets was not confirmed because we need a survey. That survey was not aligned with our design program. So with parametric modeling, we were able to code our design with unconfirmed input data, leaving the existing assets parameters in work in progress. This provided flexibility and it saved weeks in the design program as well. Well, the feedback we receive internally from our CAD team is the best proof of the success of parametric modeling in this project. And despite a higher spend in engineering, since now the engineer is the one who owns the geometrical model, we achieved considerable savings in CAD. This is one step further of what we already achieved with the BIM technology. The design process using parametric modeling is just the seed for getting a more efficient design. For example, adding optimization criteria, such as space proofing requirements, can target a reduction in the concrete or in the excavation volume, for example. Using our programming skills, we can connect different softwares to ensure the consistency in the design, or we can also generate reports or output in a more automated manner. I want to finalize the presentation with the same slide. And my conclusion is that the goals that we aimed at the beginning were achieved. The design methodology was a success, in our opinion, and a good proof of that is that after this pioneering experience within Mount McDonald, we have been using this technique in other projects around the globe in tunnels, and also within other disciplines, such as bridges and ports. Many thanks for listening, and I'll be happy to discuss further in the questions and answers session. Thank you.
Hello and welcome to my presentation for the British Tunnelling Society Harding Prize 2021. I'm going to talk about the design and construction of pile load interception transfer structures at 6 to 8 Princes Street for bank station capacity upgrade. So for the presentation, I'm going to give a little introduction both of myself and of the project. Then I'll go through the design concept, the construction sequence, the excavation and support ahead of the installation of the transfer structures, how the piles were removed, and then the reinforcement and the cast in place final transfer structure. So a little bit about me. I started my engineering career at Cardiff University and I did an MEng there, and while I was there I worked with Van Nuttall, working on projects such as Olympic Park and Tottenham Court Road station upgrade, which was my first tunnelling project. After about a year there, I identified that actually tunnelling was my favourite part of engineering, and I went to Warwick University and did the MSc in tunnelling and underground space. I graduated and joined Dr. Sauer and Partners in 2013 and have been with them ever since, working on major tunnelling projects such as Farringdon Crossrail, Bond Street Station upgrade, Bank Station capacity upgrade, which I'm going to talk about today, and there I worked for about 4 years as both in the design team and in the construction team, and currently I'm working on HS2 Euston Station. Bank Station capacity upgrade is a £550 million project with the aim of matching projected ridership for Bank Station in the coming years. It's one of the busiest stations on the network, and actually across Bank and Monument joins together 5 lines on the underground. The station upgrade aims to provide 3 new escalators, step-free access to both the Northern Line and the Central Line, and a new southbound running tunnel, which will allow the existing running tunnel, platform tunnel, to be used as a concourse tunnel and free up a lot of space at Northern Line level. As with any tunnelling project in a majorly congested urban area such as the City of London, there was an inevitable clash with building foundations. The team during concept design worked really hard to adjust the alignment to such a space so that it avoided as many piled foundations as possible. However, as you can see in the image in the bottom right hand corner here, this was not possible at 6 to 8 Princes Street. What you can see in this oval is the northern tie-in where the new southbound running tunnel meets the existing running tunnel, and the piled foundation here clashes with the new running tunnel. 6 to 8 Princes Street, the building that we're clashing with, is an 8-storey building opposite the Bank of England, and it's founded on large diameter under-reamed piles. It's currently used for banking, and it was occupied throughout the duration of the pile transfer structure and the bank station capacity upgrade project. The locations of the piles and its foundation and the pile loads are provided by the building owner, the Worshipful Company of Grocers, to the project, and from early on in the project, London Underground worked very closely with the building owner to ensure that they could deliver everything that the building owner needed and that the project needed, and that we could adhere to the legal agreement under the Transport and Works Act's order. The initial concept for supporting these building piles actually involves a gallery construction above the proposed running tunnel and the installation of active jacks to jack the piles up. However, as the design developed, it was found that this was not a requirement, it wasn't needed, and actually it was much safer and much more sustainable to provide a structure that could be completely separated and allow the building and the London Underground tunnel itself to operate completely independent of each other. So the design concept and the final alignment required the complete removal of the underream of 4 piles, and that was pile 14, pile 4, pile 24 and 25 at the back. We also identified during detail design that there was a possible clash and possible partial removal requirement for piles 3, 15 and 23. For the full load transfer structure, the structure was made up of 3 key elements, and this was an SCL primary lining, which provided access for the transfer structure construction and supported the ground load externally. Then a concrete arch would be constructed. This would transfer the pile loads along its neutral axis and into the ground. And finally, the tunnel lining would be provided to give London Underground a completely separate structure. In the early detailed design, I carried out empirical calculations to assess what size the initial SCL needed to be and the initial structural sizing for the concrete arch itself. Based on this, the geometry of the transfer structure that you can see was developed. So while I was carrying out my detailed design and while other members of the team were running the finite element calculations, a building damage assessment was being carried out for the superstructure at 6 to 8 Princes Street. When we understood more about the design concept and the building requirements themselves, it was actually identified that the transfer structure was required for future capacity only. This would enable any developers in the future to have a greater capacity of foundation should they wish to rebuild 6 to 8 Princes Street. So with that knowledge in mind, knowing that we only needed to provide capacity for future structure, the project decided to construct the pile intersection structures, the load transfer structures, as part of the normal excavation and support sequence. And we grouped these into 2 groups of 2. So the first structures were for pile 4 and 14, and the SCL lining was excavated and the piles were removed as we went through. We decided to continue all the way to piles 23 and 15 because we knew that these were extremely close to the running tunnel alignment, and that there was a significant risk that we might have to provide additional structure to partially support piles 15 and 23. Luckily, we didn't need to do that, but the underream of these piles did encroach into the running tunnel, and I can talk about that a little bit later. Once the primary lining was in and we knew exactly what the underground situation looked like for most of these piles, we installed the pile transfer structures for piles 4 and 14, and then finally continued on towards the northern line southbound running tunnel. You can see the existing tunnel here to the top of the picture. We got extremely close, and the running tunnel was operational throughout the duration of the construction of these transfer structures. Finally, the third transfer structure was installed for piles 24 and 25. We decided to install one transfer structure for this location because the piles were so close to each other, and we were quite constrained by piles 23 and 15 behind. You'll also see that the transition is much steeper here than it was for the previous 2 piles, and this is because we wanted to make sure that we avoided clashing with these piles as much as possible, and we minimised the impact on the building foundation where we could. So on the right-hand side here, you can actually see piles 23 and 15 exposed in the running tunnel face, and you can see that we did expose quite a large amount of the underream of the pile. Under the legal agreement with the building owner, we were allowed to remove a portion of the underream only, and we were quite lucky with the location of these piles and the construction installation tolerance, and actually we didn't have to encroach at all on the pile shaft, which meant that we didn't have to provide a load transfer structure. On the right-hand side, you can see pile 14, and this is one of the piles that we exposed, and a typical location for the piles. So 4, 14 and 24 were all in quite a similar location towards the right-hand side of the face. We were quite lucky with this location. It meant that we had good access for excavation using mechanical means to both the left-hand side and the right-hand side of the pile, and we could get in and expose as much of the pile as possible ahead of removing the majority of the pile for the tunnel to go through. My role at this stage was supervision on site, so I was making sure that the excavation met exactly what we needed as part of the design, and that any of the exposed piles and the identified piles were in the locations that we assumed they would be, and that we wouldn't have to construct any of those partial support transfer structures. One of the key elements of what we were doing was monitoring, and see here that we monitored the piles and the pile toe level continuously as we went through. During the primary lining installation, we installed that to allow for the construction of the transfer structures, and I oversaw the installation of this and the concrete testing, which was in line with the specification for SCL tunnel structures, which I'd written as part of my design role. So I was able to use that knowledge to make sure that actually what we were delivering met exactly what we needed. We used an EDM for assessing the thickness of the primary lining, and this use of EDM technology and finite element analysis allowed us to construct this unusual tunnel shape. It's much more of a horseshoe shape than is normally seen in soft ground, and we've moved away from that round tunnel shape to prevent undermining the adjacent piles. But in order to do this, we did provide elephant's feet, and I did carry out bearing capacity calculations to make sure that the clay could actually support every single part of what we needed to, of all the loads within the piles. So one of the most exciting things I think I've ever seen on site, and one of the biggest parts of this project, was the pile removal for the underreams at 6 to 8 Princess Street, and I was actually really lucky to be there for the completion of the first separation. During the design development, we spent quite a lot of time trying to make sure we got the right separation method, and again, this was a collaborative moment between the construction team, the designers, London Underground, and the building owner to make sure that the piles were not damaged, or any damage as minimal as possible to those piles that were going to remain in situ, to allow them to carry out that load transfer in the long term. In the end, we selected coring. This allowed us to be quite precise with the cut location, and again, this tied into the design calculations that I'd done earlier on, which were focused on the load transfer happening at the neutral axis of that concrete arch. On the right hand side, you'll see pile 25. Now, this was the only one that was in a more tricky location than the others, but survey and early building information allowed us to identify that this would be slightly further to the left than the other piles and slightly more to the edge of the tunnel structure. And in order to make sure that the cut wouldn't sit outside of the primary lining, but also wouldn't give a shear plane, we decided that coring would allow us to step the cut of this pile while still concentrating that load within the centre of that arch. Another key element of the design was the reinforcement. My initial calculations focused not only on the bearing capacity of the ground, but also on the capacity of the concrete structure itself and the reinforcement. And the final design was actually based on my initial sketches. The concept we used was like a basket cradle supporting the base of the pile and using the adjacent bars, so you can see here, that come underneath the pile and transfer the load to the arch and actually along the structure as well. So in both directions, a longitudinal transverse direction, to transfer that concentrated pile load across the whole transverse structure and into the ground below. During the installation of the reinforcement, I was checking the design, the installed bars to make sure that it matched the design. And actually, one of the steel fixers came to me and said he wasn't happy with the design in the way that only a passionate tunneler can communicate frustration with a design. And immediately, knowing that it was my design, knowing the finer element that had gone into supporting this reinforcement design and where the stress concentrations were, I went back upstairs, I adjusted the reinforcement design, I wrote an FDCR, and we were able to actually introduce a few additional bars that meant that for future transfer structures, it was much simpler and quicker and easier for the team on site to actually install the transfer structures. And I think this is one of the key elements that allowed us to really be successful in delivering the transfer structures. So the final element, the cast in place structure, this was carried out in 3 stages, again with key philosophies for bank station design in our mind, which was making sure that when we constructed it, it would be as safe as possible. And we poured it in 3 stages. So we poured the invert, then the walls, and finally the crown. And we adjusted the bar laps and the design to make sure that this was possible. This allowed much safer access and much safer platform access to the crown in particular, which you can see in the photo on the right, to make sure that everything met the standards that we needed to. We actually cast the insides of the transfer structure flat because as part of the structural separation, we were going to install a separation material between the final tunnel lining and the transfer structure itself. And this was Flexel, which you can see here, and it's actually a flat board. So we made sure that we accommodated construction materials in the final design. And this is the final transfer structure design. So you've got transfer for 4, 14, and finally 24 and 25 at the back there. And it was an extremely successful design all the way through to completion. And I think the only reason it was that successful is because of the collaboration and the working together and the communication between the team on site, but also including the building owner, who even came onto site actually during the construction to see what we were doing on site. And I was absolutely honoured to have been a part of this, and thank you very much for listening.
Hi, good evening. I'm Christina. I'm currently a section engineer at Thames Tideway West as part of the BAM Nuttall Morgan Sindall Balfour Beatty joint venture. And I'm going to talk about COVID-19 and the effect it had on our tunnel boring machine on the west section of the Thames Tideway Tunnel. For those of you that don't know the project, it's a 25-kilometre long tunnel from Acton storm tanks in the west of London to Abbey Mills pumping station in the east, and it has several associated connection tunnels. It's designed as an overflow sewer. The current Victorian sewer is well over capacity and means that millions of tonnes of sewage enter the Thames each year. My presentation will be on the west section where I work, and the main drive from Carnworth Road to Acton storm tanks. I'm sure you don't need to be reminded of COVID-19, but a slight refresher of where we were in early 2020. In January, the SARS-CoV-2 virus was first identified in Wuhan, China. It seemed very far away then, slowly crept closer, first to Italy and then to the UK, and by early March, it was probably running rampant throughout the UK. And in 23rd of March, we went into lockdown. So where were we on Thames Tideway West? We'd just mined about 4 kilometres under the River Thames. We were approaching Hammersmith Bridge, pictured in the corner there. We'd even had to, this is a very critical asset, we'd had to move the route 10 metres further south, the furthest we could within the limits of the DCO, to avoid our impact on the bridge, which had microfractures had been discovered, which meant it had been closed to all traffic except for pedestrians and local buses at the time. And coupled that with COVID was quite a stressful period, but on the 29th of March, we stopped under St Paul's School playing fields. But why did we stop at all and not push through despite the pandemic? Well, we found that our staff numbers were dropping off considerably. For those of you that have not been on a TBM before, it's not an ideal place for social distancing. You can see a pre-pandemic picture there of how crowded the cab can be. We also experienced firsthand how overstretched the emergency services were, which is not ideal in such a high-risk environment. But most of all, it was the personnel producing. TBMs are great, they're exciting pieces of kit and machinery, but they're not very useful if you don't have the men and women to man them. And slowly but surely, fewer people were coming into work each day. Some were considered high risk, and them or their families were shielding. Some were self-isolating or had symptoms. And a lot of our workers are from Ireland or Germany, and they would go home for their long weekend and wouldn't come back, either because they couldn't or because of fear of being stuck in the UK, far away from their families in what was quite a difficult time. You can see from this image quite how many people were off due to COVID by the time we stopped, and how it really wasn't possible for us to continue. But we did continue up until the 30th of March, a week past when lockdown was introduced. And just to show quite how challenging it was, this is a Nightingale plot showing the deaths registered in England and Wales. Deaths tend to lag behind infections by about 2 weeks, and you can see we probably worked right up until the peak of infections. But we did continue, and this was mainly down to trust and communication, in my opinion. We had the usual flow of information from the project managers to the shift leaders, by whom I mean the engineers and the pit bosses, down to the shift. But what's equally critical is the feedback we had. This allowed us to have information going back up the chain, which meant we modified our processes and improved things while we were still tunneling and progressing. But with other sites closing, lockdown soon announced, panic was setting in, and it was equally critical to have a direct communication from the project managers to the shift. The picture below shows the tunnel manager briefing a letter from the project director explaining the quite generous financial support Tideway were going to give to anyone legitimately affected by COVID, as well as why we had to continue past Hammersmith Bridge and how we would do so. My experience had not been of so many people leaving until I saw these numbers and investigated it further. I was on shift 1, but I plotted briefing attendance per shift to compare it, and you can see there was quite a variation between the different shifts. So I was quite intrigued. I created a survey a few months ago and carried it out among the shifts to try and understand a bit better why this might have happened. And you can see on the left that all shifts were kind of equally anxious about the situation. So it wasn't fear alone that meant people didn't come in. However, what did vary quite significantly was how they rated the communication from their shift leaders, with shift 2, which had quite unsatisfactory view of the communication, also posting the fewest personnel coming in. Shift 1, conversely, had quite positive views of the communication and lost very few people. I myself was on shift 1, and I can say we had a pit boss who inspired a lot of trust. We had a shift manager who was very competent, very experienced, kept calm, and also was German and led by example in staying right until the very end. As the shift engineer, I was a critical link between the shift itself and the office, and I had a great rapport with the men who felt they could ask me questions, and I had enough knowledge and was calm enough to answer their questions and help allay some of their fears. But we did eventually stop. First, we got past Hammersmith Bridge. You can see here the settlement profiles. The blue dashed line shows a best fit for our face loss. The measurements were taken just after we passed and stopped. And we significantly above the green, amber, and red trigger levels lines shown there. So despite all the distractions, it was really quite successful at passing this critical asset. And I was involved in managing some of the shutdown and showing that we carried everything out safely and the TBM would be in a good position when we came back. So here are some of the photos I took to show that. We cleaned the grout lines, as well as stopping the ring, continuing the advance so that the ring would be supported, but also the accelerator ports visible to clean those as well. We closed man locks and material locks, avoided ring settlement by supporting the ring also by ram cleats and chocks, washed down gantries, filled the gearboxes with oil to stop them seizing up, cleaned the ring build area as well as installing a camera there. We already had cameras in the cutter head and at the back of the machine, and these allowed us to monitor the TBM remotely. And then we left, and we didn't know when we would be able to come back, which is quite challenging. Normally for a Christmas shutdown or a period like that, you know exactly how long you need to maintain the TBM for. You have a team on call, and we didn't have any of those. So quite a lot of preparation was involved and monitoring. So the critical things to monitor were the face pressure and the ring build pressure to ensure we didn't have excessive settlements or the TBM moving uncontrollably. The face pressure we increased so that to account for the small drop we expected, but as you can see, it then leveled off and we were well above the 1 bar we were aiming for. So it was a success in part due to the very easy London clay geology, but also to the great stoppage procedure that we had in place that I helped control. And then we prepared for a restart. It was quite a quick turnaround. I believe we were the last TBM on Tideway to stop and the first to restart. And I was part of a very small team that prepared for this. Normally, as a young engineer, you have, should we say, less experience than others, and sometimes not a slight disadvantage because of that. But no one had any experience of COVID, so it was quite nice to be on a level playing field. What I did have a lot of experience on was this particular TBM, having spent more than my fair share of time on it. So I was able to analyze where people worked and where we might start having issues for social distancing, and created this diagram. So people working close together, we couldn't avoid it in the operator's cab and also where the backup men work. So they were issued with FFP3 face masks and were required to wear them in such cases. Areas which were possibly for concern were the ring build area. We were able, though, because of our boltless segments, to quite easily maintain a 2-meter distance. The canteen is quite small for the 18 or so people who were on a TBM. We had to limit this to maximum 2 people. We staggered breaks, and we also actually opened the antechambers of the refuge chamber as an additional place that people could have a break in. And we have quite narrow walkways. The segment crane and grout crane operator work within these walkways as well. I had quite a lot of trouble finding a solution to this. You couldn't create a route around them because they block both above and below. So our real solution was just briefing out again, social distancing, having these FFP3 face masks, and really emphasizing not just going up and down unnecessarily, waiting until these workers were out of the way and had finished what they were doing. And it turned out to be quite successful. I've listed here some of the additional COVID safety measures we brought in, just to highlight a few of them. I think travel arrangements were really important. It's quite easy to, well, not easy, but it's easier to control what's going on in your own site. It's not very easy to control the outside world. Handovers of the face meant that if there had been an outbreak on a shift, it wouldn't have spread to the other shifts and we'd have been able to continue. We were able to do that because, again, stable clay geology, the 2-component grout we had, and also the trust in those like myself, the shift engineers, to control the pressures along with the drivers and ensure the TBM was in a stable position with the back feed on before leaving. I had particular influence on bringing in a night shift cleaner. Hygiene is not always top priority on the TBM, and it now needed to be. We'd also previously rearranged the canteen in such a way that we still had benches, and I felt it wasn't really working. It had reduced seating and just meant men crowded onto the benches. We instead brought in chairs of my suggestion, and that's been very successful, the new layout, and we've kept it since. And I also found a way to register who was at briefings without scanning or signing them in, which reduced contact. Did we do a good job? Well, we did a survey in June and everyone seemed pretty happy, and we didn't have any outbreaks on the TBM, so it was a success, I would say. What can we learn from it? Well, I think flexible working is important everywhere, but also if you're not production staff on a TBM, it makes the job perhaps more appealing to some people and you can increase retention, as well as increasing the space we might have for welfare if people are coming in once or twice a week rather than every day. We found changing at the face didn't necessarily mean greater production. In July, Tideway experienced its best week of production so far, and that was on TBM Rachel. I think greater automation is required. That we'll have to social distance for a while, and reducing the personnel on the TBM is a key way to do this. Positions such as the backup men are quite repetitive, involve manual handling, and are ideal really to be mechanized. It also taught us the importance of monitoring. We might not have COVID-19 again, but in other countries, especially, you might have strikes, you might have severe weather events, especially with climate change, or just political instability, and have to leave the TBM. They're expensive pieces of kit and you want to be able to monitor, and it would be even better if you had remote backup systems where you could alter the face pressure if you find it's dropping. And finally, in September, our COVID-safe TBM Rachel broke through, and it was a success, which is great. We had no COVID outbreaks, as I said earlier. Thank you very much for listening to my presentation.
Yeah, well, thank you all for taking the time to do your presentations. Yeah, Benjamin, my question is, can you explain how the structural design interfaced with the parametric design, and was this interface in two directions?
It can be done. So this is one of the lessons learned. It can be done. However, in this specific project, it was just one direction. So basically, we were ensuring that the geometry was always aligned with the model. However, we were going by means of revision numbers, and we were dealing with that in that way. But yeah, the findings on that is that that can be done, and it can be a much closer interface between structural modeling and the beam modeling or parametric modeling. That's something that it can be done, and it's been studied, and it will be applied in the future.
And then any questions from Chris?
Yeah, hi there, Benjamin. Really enjoyed your presentation and reading your paper. I'm not an engineer, so you've got to bear with me. I'm not going to be asking you any tricky technical questions, but I am really interested in the efficiencies and, in particular, I suppose the benefits to not just this project, but the industry. Could you estimate what are the cost benefits, do you think, to this project, and roughly how can that be translated to other projects?
Yeah, well, there are two. I will speak from two different cost benefit. One, the first one is the one that can be observed in terms of the budget. So what we observed by means of using parametric modeling was a reduction in the budget, which is usually used in the CAD technician or in the BIM modeling, and that's a percentage over the whole design budget of the project. So this could be observed, and that's been shown comparing to other different or to other similar projects in the area, as I showed in the presentation. The other one is something which is not so easy to show in numbers, but we experience a certain in many different ways the advantage of that. And one of the main issues there, or one of the main advantages, was that we spend much less time redoing or remodeling and being instructing the CAD technician how to model the new revision or the new modifications, and also checking the 3D model, which is usually a very tedious process. With that, the main advantage is that all that time we usually used to spend in those matters could be invested in exploring all the different solutions, in implementing all the things that sometimes you cannot, basically because you just don't have time, or you have or the program is limited. So I would say there is it can be, to summarize, it can be seen money reduction in a way, but in other aspects which are not cannot be put in money, but in terms of quality, it mean a big improvement.
Good answer. Thank you very much.
I also saw some questions in YouTube. Should we go now to them?
Yeah. My thoughts were we'll work through the judges' questions for each of the three finalists, and then we'll take some from the YouTube channel as well. So I think, are there any more questions for Benjamin from the judges before we move on to Kate?
Not from me, no.
Okay. Right. So if we could take questions next for Kate, starting with Anita.
Kate, you mentioned monitoring of the piles before they were removed. What were the projected movement compared to the actual recorded movements, and was vibration recorded during the removal of the piles?
So we predicted somewhere in the region of about 3 millimeters of movement for most of the piles. Each of the piles had a different prediction because they were all going to behave slightly differently. They were in different locations. They had different loads and were slightly different sizes. Every single one of them, after they were cut, actually moved slightly less than we'd predicted, which we thought was a success. They did move, so we did see evidence that they were loaded and that there was movement there, but it was less than the prediction, so it meant that was good and that the load was being transferred by the base slab as we'd hoped. And I've forgotten the second part of your question. God, sorry.
That's all right. Was vibration recorded?
So we had optical fibres in one of the piles. It was an optical fibre strain gauge, which gave sort of information to validate some of the assumptions, but I'm not aware of any specific vibration monitoring. Yeah.
Okay, thank you.
Cheers.
Okay, and then questions from David.
Hello, Kate. Did the pile tolerance have any impact on the structural design of the transfer structure? And sort of in particular, was there any particular location which was observed to be critical?
So we had a 525 mil tolerance on the pile location, and in order to allow for that in the design, it was designed as an arch with a point load, and we essentially calculated a different angle of where that point load would be meeting the arch depending on where it sat in tolerance. So all of the calculations that I did, I ran sort of the two extreme sides of where that would be hitting on the arch, and made sure that it would the design would be able to accommodate that. The worst case one probably would have been 25. The most critical one was pile 25, and you could see from the pictures in the presentation that was quite far to the left-hand side, and had it sat considerably further to the left than we'd hoped, then it could have meant that we would have had to go back and actually look at the design again and rethink exactly how the reinforcement would have fit it, because it would have been sitting slightly lower in the sort of the arch shape than the other three that were sat much more in the crown area.
Okay. And any questions from Chris?
Yeah, thanks, Kate. I must say that I found the whole paper and presentation incredibly fascinating. I'd really just like to know, how did you feel when I presume you're present on site when those piles were exposed? Just talk me through what you were feeling at that point.
It was really exciting. When we were all a bit whenever it's a sensitive asset, you're always a little bit nervous, and we wanted to make sure that we got this particular piece right and that we did the right thing. So when we were exposed to piles, we weren't 100% sure what the bells were going to be like. We weren't 100% sure what the quality of those were going to be like, and they actually, you can see from the pictures, they're perfect angles, and they're really actually quite well preserved and well built. And actually seeing them and seeing the size of them in front of you, it's quite overwhelming, but it was kind of exciting at the same time, I guess. It was just an absolute honour to be involved in this. It was a really, really interesting piece of work, and I really loved working on both the design and the construction.
Brilliant. Yeah, I must admit, I probably feel nervous as well. I guess the fact that those piles were not load sort of transfer, or you only needed to build a load transfer for any future potential loads. What would you have done differently if those piles that you were intersecting were actually, going to be affected by the excavation and cutting?
So that was considered during the earlier design phase, and we would have had to construct like a gallery above the tunnel. It would have been a hand-mined gallery, and then jacks would have been installed around the pile to support it. And then as we dug underneath with the full-size tunnel, we would have adjusted those jacks to support that pile as we were going underneath it. So it would have meant that the building above didn't move, and the base slab wasn't damaged while we built that tunnel. But we were lucky that when we did good detailed assessment, we found that wasn't necessary. And when we actually built it, we found that there was no visible damage to the building at all during the construction.
Brilliant. Thank you very much.
Thanks.
Okay, before we move on, are there any more questions for Kate from the judges? Okay, we'll take that then if we move on next to questions for Christina. If we start with Anita.
Hi, Christina. In your presentation, you mentioned that shift 1 managed to stay much more positive compared to the other shifts. So if this happens again, what would you do to ensure the other shifts can stay positive, like shift 1 that you were on? I do also have a second question, but I'll let you answer this question first before I move on to the second question.
In terms of staying more positive,
yes,
I think we'd have to, I think part of it doesn't start at the root of when you're panicking. It's partly luck of the draw, I have to admit, in who you have on the shift. Shift 2, who did experience extremely high levels of dissatisfaction, shall we say, was probably due to a couple of members who were really panicked, which spread that fear quite significantly. So I think more mitigation would be needed to kind of openly address those fears to calm the whole shift down. I think also perhaps learning lessons from shift 1, making sure that the shift leaders themselves are really well briefed on what the situation is and are really on board. Like we were. Because while I know that myself and my shift manager and my pit boss were really keen to keep going, we knew exactly what the situation was. Perhaps the other shifts didn't have quite the same level of communication, which is why in turn they didn't hand that on so well. Don't know if that answers the question well.
Yes, thank you. My second question is on the shutdown, the safe stop shutdown back in March last year, and for the unknown duration. How was that different to a Christmas shutdown?
So a Christmas shutdown, you know that it's for 2 weeks, so you can be pretty confident that with London Clay, etc., you're going to keep the face pressure for that long. What the main difference was we didn't know how long we were staying away for, and also the Christmas shutdown, you can be a bit more certain that if something does go wrong, you've got guys to come in. We did have guys obviously on call, and I'm sure we would have survived in the case of an emergency, but Heron Connect, who are big support of all the mechanical side of things, were all in Germany, really, the guys we were working with, so that would have been a bit of a struggle. In terms of the procedure itself, I think that was quite similar to what we'd done in previous Christmases, I believe. So I think the stoppage procedure was the same. What was a big change was the circumstances around it and how we would have been able to react.
Thank you.
Okay. Are there any further questions from Anita? If not, we'll move on to David.
No, none from me, thanks.
Hello, Christina. Following on from Anita, I have a question with regards to face pressure monitoring. What was the contingency plan if the face pressure was observed to drop below 1 bar?
So first of all, we had a 1.2 bar that there would have been an automatic notification for, I guess, the tunnel managers and people like that to warn them, so we had enough time before it dropped below 1 bar to put in some kind of procedure. We would hopefully have managed to get people on site and into the ground. And then we'd retracted the shield articulation before stopping. So we would have been able to extend that forward to increase the pressure slightly. We'd have also been able to use the de-aeration valve. And if worst came to the worst, we could push forward slightly because we stopped at 2,500 meters extension, whereas normally we stopped at 2,700 mil extension. We were very fortunate in the end. Lockdown wasn't as strict as we thought it might be, and there wasn't while COVID's been bad, it was not the awful plague we thought it might be in March, where we, like some other countries, perhaps couldn't leave our homes. If that had been the case, I don't know what we'd have done, but fortunately it wasn't. We don't have automated systems, unfortunately.
Great, thank you.
If nothing more then from David, we'll move on to Chris.
Yeah, thank you. Hi, Christina. First of all, thank you very much for your presentation and the paper. It must have been incredibly challenging to make those sorts of decisions when you don't know what the hell is going on in the world, let alone, you know, in your construction project. You were pretty fortunate, I think, on your own admissions that you were in good, friendly London Clay during the lockdown. What would you have done differently had you been in Lambeth Group, for example?
That's a very difficult question. I think for a start, we perhaps would not have had the same machine if we were in more challenging geology. We wouldn't necessarily be with the easy EPB we were with. We would have perhaps had to monitor it more. I have to admit that my only experience of tunnelling is with London Clay so far, so I can't say exactly how the Lambeth. I know that the Lambeth geology is more less certain, and you can get more water ingress, etc. But yeah, I'm sorry, I can't answer the question as well as I would like to of what we would have done differently.
No, that's fine. I guess I just wanted to explore what your mitigation measures might have been had you been in water-bearing soils.
If we'd been in higher water-bearing soils, we probably would have had to try and keep people on the TBM. During this period, there were other construction jobs which did continue, most did stop. I think if it was more safety critical, we would have had to have a team on shift monitoring the TBM at all times.
Yeah, I think that's fair enough.
Realistically.
Yeah.
Are there any further questions then from the judges for Christina? Okay. I think at that point then, I think if the judges are happy, they've asked all their questions. I think we will now go to the YouTube page, and we'll work our way through these questions. I think they're going to come in random order. So hopefully I'll get a good mix of some for each of the finalists. So I think the first question that I can see is one to Kate. Could you say something about the condition of the exposed existing piles? Were they well constructed? And this is from Ray Hobbs.
So we didn't have any as-built records for the piles. We were working just off design records. So we really didn't know what we were expecting when we got down there and when they were actually sitting in the tunnel face. And actually they were really good quality. The bells were a really consistent shape. They were slightly bigger maybe than we'd anticipated, but nothing that really was intimidating or nothing that was poor quality. Actually, they were excellently built and we were really impressed.
The next one then is for Benjamin from Michael O'Sullivan. For the known unknowns, why did PM save weeks in design by not having the survey information?
Yeah, no, thanks, Michael. That's a very good question. With the standard method, once you have such an important, input missing or not confirmed, that means that if you undertake a manual or you model the structure or the asset without knowing exactly what's going to be the final geometry, at the end it results when you get the final data, the confirmed data for the survey. You need to start from scratch as well as with the drawings. Knowing that, what we did was to prepare everything so that as soon as we had the data available, we implemented that, and the model and the drawings were well prepared to fit those changes. And when estimating weeks, I would say, especially in terms of the checking of the model and drawing production, that was a big saving of time.
Okay, and I think the next one is actually for you as well, Benjamin. This is one from Colin Everson.
Yeah.
Did you rationalise the complex geometry from the parametric model to consider buildability, such as consistent cross sections and junctions, to suit formwork reuse and architectural finishes?
Yeah, that's an interesting question as well. And yeah, we did rationalize the structure, but this is a early stage before coding the whole thing. And as I said in the presentation, first you need to design how your structure is going to look like. Otherwise, you have unlimited solutions. So you need to set some constraints or some limits on that. So for that, we needed to undertake let's say, also, it was also a parametric design or a parametric study for the previous one, so that we could define the solution. And once we have the solution, that was when we had the concept done, and there's when we could play with certain limits with the final model. So basically, if we have coded, if we allow the script to have two junctions and with certain limits of kind of geometries or junction, that makes the model manageable or made the or doable. If we code all the limitless solutions we have, that is not an advantage at all. So yeah, this is done, but this is done in an engineering way before coding the whole thing. So.
Okay. The next question I've got in from Yu Sheng Hu for Kate. How did the existing building respond when the tunnel was excavated and then when the respective piles were cut?
So because it was kind of a process that happened sort of sequentially, so it's all sort of happening together, the building obviously settled in respect to the tunnel geometry and what we'd predicted. So stage 3 assessment was carried out, and we did a 3D model of the piles and the base slab to understand exactly what we thought was going to happen when we tunneled through, and we did a staged excavation sequence of that. And at every single stage, it met or was slightly under what we were predicting would happen. So early on, we thought they'd be somewhere in the region of about 3 to 5 millimeters when we cut the piles, and that's exactly what we saw. And then when the tunnel was completed, we thought this may go up to 10 millimeters, and we saw no more than about 6. So it was pretty accurate in relation to what we were predicting, and it meant that we hadn't under-predicted, and which meant that the building wasn't damaged more significantly than we'd anticipated.
Okay, and I think the next one is also for you, Kate. What was the ground movement and settlement of the existing structure like throughout the different stages of constructing the pile interception structures?
I'm not sure if I've kind of answered that in the previous one.
Yeah.
But yeah, it was sort of about 3 millimeters when the piles were cut, and about 6 millimeters when we'd completely finished.
Okay. The next question we've got in then is for Christina from Asil. Did you make changes to the ventilation system to minimize the risk of breathing infected air within the tunnel?
In short, no, but I can say a bit more about why not. Firstly, we were probably actually better ventilated than a lot of offices and other spaces like that. It's a big 1.8 meter duct blowing air all the time. So ventilation is actually fairly good down there. We were also 4 kilometers in, so it would have been quite challenging to put in extraction or put a new duct in of any kind. And filtration wouldn't have been helpful either, because it's not extraction, it's pushing air in. So that's why not.
Okay. I think we've also got another one next for you, Christina. How significant will the automation and reduction of headcount within TBMs in the near future?
I'd like to think it was in the near future. It might be more of a midterm future, because I think things are a bit stuck in their ways, though there are positive signs, such as in the Paris Metro, they've got their automated ring build. I hear HS2 have some automatic dowels or something. I think there's a lot of potential, especially, I think I touched on it in the presentation, about repetitive tasks such as the backup men to reduce their manual handling. They're just putting in pipes all the time. Yes, things can go wrong, but you can have one man who does the ventilation, the pipes, and the segments rather than 5. So hopefully it will reduce the headcount soon. It is a factory process, though I know each TBM is a different factory, so maybe it will take a bit longer.
Okay, I think next one then is for Kate. Did you install instrumentation and/or did you monitor the pile movements? Can you share results? I think you probably covered some of this, but if there's anything else.
I guess just to say that we monitored the slab, we monitored the piles themselves, we monitored the building, and we also, we monitored the base of the piles. We had targets above and below the cut line, so that we knew what was happening to the shaft and to the base of the pile as we sort of separated. It really gave us a full picture of what was happening underground.
Next question then for Christina. Did any method statements or procedures, such as manual handling, have to change due to social distancing?
So not directly on the TBM that I can think of, but we were coming at that stage to installing our booster for the conveyor system, and we had to lift some of the conveyor system for the booster, and that was all changed pretty much to account for COVID, and it meant the works took slightly longer, but we had fewer people so that they could social distance. So it was taken into account where required during our works.
Then next one in really for Kate. What ground relaxation time did you get whilst casting the structure?
Oh gosh, not really sure I know how to answer that one. I guess the ground sort of relaxed as predicted. There was monitoring on the primary lining as well as on the piles, and all of those targets sort of moved as we expected they would do. Obviously, when we were actually casting the structure itself, because it was inside the primary lining, we had to remove the primary lining monitoring, and the monitoring that we had that gave us information was sort of the building and the surface and the surrounding tunnels. So it wasn't any sort of immediate relaxation when we excavated the ground. It had a good stand-up time. We were able to excavate sort of in and around the piles and take our time to make sure no damage occurred to any of the pile structure at all. So in that sense, it was good. So I guess a typical London clay stand-up time.
Okay. We've got time just for a couple more before we allow the judges to adjourn. Next one then from Claudio. I think this is another one really for you, Kate. Very interested in your experience of going from design to construction. From a designer point of view, what was the biggest challenge to adapt to a site role?
So actually for me, I started out on site and I was kind of going back. I've gone between the two. I've been quite lucky in the roles that I've had. You do have to adjust your thinking and adjust your expectation. But I think going from one role to another and going from either construction to design or from design to construction gives you a slightly different perspective and allows you to appreciate the practicalities of what you're designing. And it gives you a lot of good experience to know that next time you might do something slightly differently. Going from design to construction, I think, sometimes things on site aren't exactly what you're expecting them to be. When you get underground, you get the ground that you get, and it's not always exactly as you've modelled it. And I think adapting to that and understanding your design well enough to be able to adjust it to what you're actually seeing at the tunnel face is probably one of the biggest challenges.
Okay, I think we're nearly through the questions, and I think we've got time just to take this final one. And this is one for Benjamin from Asil. What systems did you employ to validate the last minute design changes in your parametric model? And was there an option to analyze the sensitivity of design changes to the construction program?
Yeah, well, the validation of the changes were done in the exactly same way as any other early changes. What parametric modeling provided us was the option to do that, to react quickly and to react faster to those changes. However, that always wasn't sure the validation and the quality and the other buildability issues, such as interfaces with in this case cables or other services involved. We also had the standard process of buildability reviews with the client and with the and with the contractor. So we didn't undermine any quality or any validation issue by means of using a system which allow us to react to changes in a quicker way.
Okay. I think we've reached a point now where we'll draw questions to a close. Want to really give my thanks to all three finalists this evening, particularly for all that you've done in terms of putting all of this together during a really unusual year. I think for all of us, we've been absolutely overwhelmed with the number of entries that we had for the competition this year. And I think you're three very worthy finalists. And I don't envy the role that the judges have to go in if they could adjourn now to go and make their decision. And later on this evening, after our special guest, we will make that announcement. So really wanted to thank the three of you again for coming here this evening and giving us your presentations. So thank you very much for your time. Okay, so if we move on now whilst the judges adjourn to our next segments for this evening. And I'd like to announce that we have a guest with us this evening. So I'll just allow Divik to move to the next slide. Okay, so this evening we have got some special things for you, and hopefully some of you, if you joined us early this evening, you may have heard a couple of things before we opened tonight's proceedings. So as you know, this is the BTS 50th anniversary year, and we felt it's important not to just celebrate but also to really reflect on our history. So this evening, I'm very pleased that we've got Nancy Kerr and Benoit Jones with us for me to sort of talk you through some of what we've also been up to and what we want to share with you this evening. So we don't just want to celebrate, we want to look at not just the dates and the landmark projects and the prominent engineers, but the stories that we've got about all of us. That's the hard work, humility, and sometimes the hubris, the everyday courage and everyday fears, the endless boring repetition when things don't go well, and when they do go well, the pressure amidst the noise and the dust when they don't, the friends and the colleagues we have lost or seen irreparably damaged, the ones who still stand by our sides. This year, as many of you know, we are producing a book of stories, and we've been doing this for at least a year now, as we have so many that we have been shared with us across so many of you, and there are still some coming in. But probably fewer of you are aware that we've also commissioned Nancy, probably the best folk song composer of our time, to write a suite, that's right, a suite, not just one, of folk songs about tunnelling. And we are really pleased with the results. And the songs, for those of you that have been checking out the BTS emails, have actually been released today. So as a really special treat, we have got Nancy here with us tonight, and we're going to play you a couple of the songs. And actually, whilst we do that, we're going to talk you through a little bit about them, the inspiration and how they've been put together. So tonight, myself and Benoit will be doing a little bit of a double act, as Benoit has really been the force about in terms of making this happen, and really kind of the concept and the idea of something that's really quite unique and special to the British Tunnelling Society. I'm personally not sure if anyone else has done this sort of thing within the engineering industry, and I think it's something that's really special to us and a really great way to share these, and hopefully something that we'll be hearing sung down in the tunnels when people are on a particularly hard day. So let's see what happens in the future. So really, as a little bit more, the work we do, as we all know, has a huge beneficial impact on society. We've got from Bazalgette sewers to the London Underground, to the canals and railways, tunnels of the 18th and 19th centuries, all the way through to things like the Channel Tunnel. But the stories of those that build them are really rarely told. There are many folk songs, as you will know, about going to sea, going to war, farming and weaving, but I don't think there are many about construction, let alone tunnelling. So this is really something that we think is very unique to us. So I think without further ado, I think we'll move over really to sort of understand a little bit more about this project from Benoit and Nancy.
Okay, thank you, Kate. Nancy, nice of you to join us tonight. It's a special pleasure for us to have you here. And so, was this an interesting challenge for you? And how did you go about researching and writing these folk songs?
Thanks, Benoit. And yes, thank you so much, Kate, for that lovely introduction. And thanks to the BTS for making this happen and for inviting me in. It's been fascinating. So you're right, Kate. At first, this does seem like a kind of unlikely partnership of sort of folk song and kind of old ways of singing and telling stories, and this incredible industry and set of experiences. There is actually a strong history, as you'll know, and as Benoit knew, I think, which is what kind of informed this, of telling stories of sort of social history and civil engineering and all sorts of different industrial kind of narratives in folk song. There is, in fact, a folk song about tunnelling. So Ewan MacColl, who wrote the song Dirty Old Town, as well as many other kind of industrial folk ballads, wrote a song called Tunnel Tigers. I think he wrote it in probably the late 50s or early 60s. And that's quite an anthem of the kind of folk scene, in that he wrote about different counties of Ireland from which tunnellers had come to London to, as he says it, drive a tunnel through the London clay. So that was one area that I sort of used in my research, and one reason that I knew that this would be a fascinating project to be part of, and that I knew I could play a role in. So to write this suite of songs, I think there were a number of things that really inspired me, apart from that kind of knowledge of how folk song tells people's stories. One thing I did was that my stepdad is an engineer by training, and also we are a big kind of canal family. We've had boats in our life and in our family for a long time. So I read LTC Rolt's biography of Brunel and got a lot from that. I went online and I looked at kind of tunnellers' social media kind of places and looked at how people talked about their work and the industry. But I have to say the main kind of point of inspiration was the stories from the kind of memoirs of people who have contributed to the 50th anniversary book. There's a real sense of kind of poetry in the way that people talk about their own work and about their own industry and their own challenges and their own lives. And that is really a gift to a folk singer who wants to, capture those experiences in music. All you really have to do is just set a lot of that to music. And that was my main inspiration. I've learned such a lot, and I really hope that people enjoy seeing their stories put into song.
Sorry, just unmute myself. Thanks, Nancy. It's been such a pleasure to work with you, and it's been so easy from my point of view. So the first song we are going to play is called Getting a Rise. So could you tell us a little about it and where it came from and the title and what it's about?
Yeah, lovely. So a big kind of chunk of my family are from Kent, and I must have been through the Dartford Tunnel a billion times. So when it came to writing a song that was kind of what I wanted to do was something light-hearted but also very real, and again, when it came to writing this, the real gift was the memoirs of particularly tunnelling men working on the Dartford Tunnel, many of them from Donegal and other areas of Ireland. So I really drew on, I think, particularly the accounts of the Vaughan family, and then a couple of other workers from Ireland who worked, I think, on the perhaps it was the Black Wall. Anyway, I kind of collated a kind of bunch of stories about those particularly challenging jobs. There's, like I say, my family are from Kent, and there's a song that my mum used to sing, which is again a song about work. It's a hop picking song called Hopping Down in Kent. And actually, I'll just sing you a little bit of it because the Dartford Tunnel song that I wrote is very much based on this. So the families that used to come, as my family did, from the East End and other places to pick hops in Kent, used to sing a song that went, "Some say hopping's lousy, I don't believe it's true. I think I'll go down hopping and earn a bob or two with the T-I-O, T-I-O, T-I-E-I-O." And it's all about the kind of hardship of that migrant worker experience. Anyway, again, I thought that was a nice kind of framework to use for this song about making the Dartford Tunnel, and about the kind of challenges, especially the physical challenges of that particular job. So I borrowed that song that I learned from my mum and I made it into a song called Getting a Rise. And again, that thing about how people telling their own stories is always, I think, the best way of hearing a story and the best way of telling it. The way that the Vaughan family talk about the kind of process of becoming a tunneling person and of being involved in being like a lock keeper and decompression and all those kind of challenges, it's just really beautifully put. And the humor really comes through as well. So the story, the title of the song and the theme of the song, Getting a Rise, is from saying, you know, the foreman saying to you, do you want to get a rise? And you're saying, yes, please, I'd love that. And the foreman saying, well, you know, every time you come up in the lift, you'll be getting a rise. And a lot of the memoirs are so full of that kind of crack and that kind of spark that, again, it was a bit of a gift to a songwriter. And I think, you know, fair play to you as well, Benoit, because I think I get the impression you know folk song, you know how music works and how stories put into music work. And you did say, could we do something that was a bit like a kind of shanty or a kind of children's song, and very much a song that's meant to be joined in with and kind of has the rhythm of work to it. So yeah, that's Getting a Rise, very much a kind of Dartford kind of situated work song or shanty.
That's great. Okay, DJ Divic, can we...
As I was going to Dartford all on a winter's day, those lads of Kent were downward sent with the pilot underway, and we were getting a rise with the T-I-E-I-O. We were getting a rise with the T-I-E-I-O. Well, we were feeling jammy, gone down to 8-hour shifts. Then the foreman cries, you'll be getting a rise every time you take the lift. And we were getting a rise with a T-I-E-I-O. We were getting a rise with a T-I-E-I-O. The crack was up to 90, but the foreman's face was drear. There's industry in the old country, but beggar all happening here. And we were getting a rise with a T-I-E-I-O. We were getting a rise with a T-I-E-I-O. And it's oh the cruel compressor, and oh the miner's moans, and oh the shock of the medical lock when the wind gets in your bones. But we were getting a rise with a T-I-E-I-O. We were getting a rise with a T-I-E-I-O. Well, love can move a mountain, but we could shift the moon. We could travel to hell, then sleep so well that we wouldn't wake up till noon. And we were getting a rise with a T-I-E-I-O. We were getting a rise with a T-I-E-I-O. Well, some say digging's a lousy, but miners know it's grand. When you're down the hole, you'll bless the soul of a Dartford tunnelling man. And we were getting a rise with a T-I-E-I-O. We were getting a rise with a T-I-E-I-O.
Okay, that was great. So the next song we're going to listen to is called Sweet Teredo. So could you tell us, for those of us, I know obviously because I've read all the stuff already, but could you tell us what is a teredo and what's the inspiration for the song?
Yeah, so the Teredo navalis, I think it is the naval shipworm and also called the termite of the sea. So it's this kind of pest that has riddled ships with holes since there's been shipping. And so, yeah, any historians will know and engineers will know as well, I think, that this is this kind of part of the mythology, I think, as well as the history of tunneling. This idea of Mark Brunel kind of, in my mind, kind of kneeling down and seeing, it's a bit of a Jurassic Park moment, really. It's a bit, they do move in herds, it's sort of that he kind of sees the effect that this mollusk has had on wood, and sees that this creature kind of creates a kind of protective tunnel for itself while it continues to kind of eat its way through the ship's hull. And that becomes this kind of inspiration for the idea of some kind of protection, and eventually evolves into the Teredo shield. So again, this is a bit of a gift to a writer, because it combines, well, my two really intense interests, really, which is, innovation and engineering and thought and construction and kind of, the kind of creation of new kind of, urban and engineering innovations. I think that's fascinating, and that's what we've been singing about as folk singers since the Industrial Revolution. And then you've got nature and conservation and the inspiration that we get from the natural world. So before this, I wrote at least two kind of concept albums about nature and what nature gives us as humans, and how often we get inspiration from nature. So yeah, this moment of kind of coming together of nature and engineering innovation was the inspiration for this song. I said that a lot of my family come from Kent, and the other bits of my family come from the northeast, where there's this very rich mining tradition, and this very kind of close to the surface, if you'll forgive the pun, there's a very close to the surface awareness of how important mining families and mining people are to the infrastructure of our kind of lives in the northeast. So I kind of wrote a half tunneling, half mining song, and it's about this kind of, I don't know, it could be a lover or a partner or a parent thanking this little snail thing for giving this engineer the idea for protecting miners and protecting tunnelers. So to me, that brings together kind of everything, really. As I say, the kind of sense of environment and nature, and the kind of timelessness of innovation in that setting. So yeah, it's called My Sweet Teredo, and this person is kind of reflecting on what Brunel gave us and what people have run with since then to be able to create tunnels and to keep, as she says in it, to keep my minor laddies safe. So yeah, this song will be premiered actually tomorrow. There's going to be 2 pieces of radio play of this piece, one on Sheffield Live Radio and one on BBC Radio 3 in the evening. So this is kind of a bit of a kind of romantic heart to the song suite. So yeah, My Sweet Teredo.
I hope the next TBM that gets christened gets called Sweet Teredo. That would be wonderful.
On Dockland sand, our future's father surveyed a sunken ship, his hand upon its beam, soft sea-born soul, some sweet Teredo, turned trusted oak to bone, turned oceans into dreams, that little friend, through great invention, grew to iron size below the riverbed, now fortune fair, and great Teredo, keep the air above my minor laddie's head. I fear the stones below us rolling, shifting shale and industry, let life prevail. my sweet Teredo. Keep him whole and bring my minor lad to me. Brave engineers and all their credo may lose 100 men or launch a dozen ships, fortune in you, my sweet Teredo. Keep the breath between my minor laddie's lips. I feel the stones below us rolling, shifting shale and industry, let life prevail, my sweet Teredo. Keep him whole and bring my minor lad to me. Oh, Mother Thames, beware our lovers, for they're the ones who coax your London clays apart when rivers rage, my sweet Teredo. Keep a cage around my minor laddie's heart. I feel the stones below us rolling, shifting shale and industry, let life prevail, my sweet Teredo. Keep him whole and bring my minor lad to me. On Dockland sand, our future's father surveyed a sunken ship, his hand upon its beam. Some weary soul, some little sailor, turned trusted oak to bone, turned oceans into dreams. That little friend, through great invention, grew to iron size below the riverbed, fortune and you, my sweet Teredo. Keep the air above my minor laddie's head when waters rise, my sweet Teredo. Keep the light within my minor laddie's eyes when rivers rage, my sweet Teredo. Keep a cage around my minor laddie's heart when ships come in, my sweet Teredo. Keep the breath between my minor laddie's lips, your steady heart, my little traveller, warms the blankets on my minor laddie's bed. I feel the stones below us rolling, shifting shale and industry, let life prevail, my sweet Teredo. Keep him whole and bring my minor lad to me. I feel the clay below us rolling, ragged shale and industry, let life prevail, my little traveller. Keep him whole and bring my minor lad to me.
Okay, well, I hope you've really enjoyed this evening, allowing us to introduce to you two of the songs from the suite that we have. And I really do encourage you to all go and follow the link that I think Benoit has discovered and described to you today, and also that Divik has put in the chat on YouTube. And also, if you're a BTS member, you'll have had all of the links through. And please also check out the two viewings that are going to be on radio tomorrow. So please spread the message far and wide that BTS has developed a suite of songs with Nancy. And like you say, it would be really interesting and really encouraging to hear them sung underground, and really just as something really quite memorable to share those stories of something that's been created for our industry. So we want to really thank Nancy for going on this creative journey with us. It's been something really different, and something that I don't think any of us will forget. So thank you very much, and also thank you very much for coming again this evening and explaining about how it all worked this evening. We've been really enjoyed working with you.
Thanks, Kate. Thanks, Benoit. It's an honour. Thank you so much.
No, well, thank you very much. I think we I understand that the judges are still going in debating this evening. So we have one other item for you. I believe Divik has got lined up that we've got another short video that we're going to show you, as I've been informed that the judges need a couple more minutes. As I said before, I think we had 3 very close presentations this evening, so we'll give them a couple more minutes. So I think, Divik, are we able to share?
The wonderful thing about tunnelling is it actually goes across different sectors. So you can be a tunnelling engineer and work in rail, work in water, work in highways.
Because the space in cities are growing so fast and the space on the surface is just disappearing, and we need to go underground. And so the demand for engineers who know how to construct underground is just increasing. And so that's why the course is particularly relevant at the moment.
The modules cover pretty much everything you need to know about tunnelling in underground space. So from health and safety to design to construction management.
So the course is structured in 1-week blocks. They also enable the course to be taken part-time, and they can come and just for the week-long modules. And then they can go back to their work afterwards in between the modules.
You've got people who are coming from industry and able to bring real life experiences and case studies into an academic environment. And that for me is quite unique with this particular course. I haven't seen that in many places.
They are very knowledgeable, and learning from them, I can actually relate and learn on how to do better when I bring my work back after this course.
I would say this course focuses more towards what you will experience when you actually graduate and start working.
We get to do a realistic group project at the end of the MSc. That really helps with the transition into the industry.
The design of a tunnelling scheme, but also working out how it's going to be built, and even how the contract and how it's going to be managed and organised.
The course attracts students from around the world.
A lot of them have come from work, so they've been working in industry for the past couple of years, coming in with that industry knowledge, whereas I've come straight from university.
Like for me, for example, I've worked a couple of years, I may have forgotten certain things. So it's interesting to learn from someone who has just graduated. I see things in a different way as well.
We've had one young lady who joined us in 2017. She specifically has been involved in quite a number of overseas projects, which I think she's really enjoyed. Again, we did another annual visit to meet the students of the master's course, and we had another postgrad join us, and we were able to offer him sponsorship, and now he works for us permanently.
I'm currently working on the bank station capacity upgrade project, on the final bits of the design of that project.
I think this is a really exciting time to enter into the tunnel and underground construction arena. There's so much work, not just in London, but in the rest of the UK and abroad. And one of the great things about this industry is it will take you absolutely everywhere.
When you graduate from the MSc at Warwick, you will find that everyone in the tunnelling industry is trying to employ you. It is very easy getting a job with an MSc in tunnelling.
I got an offer from ACOM, so I'm starting as a graduate tunnel designer in October, which I think is really good, given that I started the course in October and I got a job in December. And I know from personal experience, when I was trying to find a job after the undergrad, it was much more difficult than that. So it definitely opened up new opportunities for me.
Okay, well, welcome back. I have just heard in from the judges that they have finished their deliberations. And I am this evening very pleased to share the message from them. As many of you will probably expect, due to the high calibre of what we've had this evening, the judges have informed me that it was incredibly hard to separate a winner. They enjoyed all 3 fantastic papers and presentations. So the words that I have been given by the judges this evening is that overall, the candidate that they have selected, that they felt had the overall strongest technical offering and potentially has the greatest interest to our industry, the winner this evening is Benjamin. They consider that Benjamin provided the strongest total offering, good technical understanding, coupled with very clear explanation of the benefits of parametric design which presented such that the results were readily understood. So congratulations, Benjamin. As I said before, 3 very worthwhile presentations given this evening, and I look forward in the future being able to present you with your prize in person when hopefully at a very short period of time in the future, we'll be able to do that in person in London shortly. So thank you again to all 3 finalists this evening and to our judges who have spent time going through all the papers and all the entries that we've had this year for the competition. So thank you very much and congratulations again, Benjamin.
Thank you. Thank you, Kate.
So thank you very much.
May I speak? And thanks to my, all right. No, thank you very much, really. I'm really happy with that. First, I want to tell Christina and Kate that they were amazing presentations and it was just impressive. I learned a lot from them, and many thanks to the organization as well. I think Vivek, Kate, and the whole team of the BTS made a really nice effort, and it's just the task they are undertaking is amazing. Thank you.
Well, thank you all very much for all of your time and efforts. This is the first time that we've done this online in this way. Certainly slightly more involved than when we would normally do it live in the lecture theatre. So really want to thank everyone for all of the work that they've done, all of the fantastic entries and everyone's time to put this together this evening. So thank you once again to all 3 finalists and congratulations again, Benjamin, on your win. So this evening, I've got just a couple of announcements. So I think, Divik, if we could go to the next slide. So just as a reminder, we are continuing with doing our post-lecture socials. So please come and join us this evening on Zoom. The virtual bar should already be open. So please follow the link that's on screen, and I believe will also have been put in the YouTube chat. So if we could go to the next slide. Another one then, just a reminder that the MSc Tunnelling and Underground space at the University of Warwick is open for applications for entry in October 2021. You can do this as a 1-year full-time or 2 to 3 years part-time. And as a reminder, there is a BTS bursary available. And also in a couple of days' time, there is a virtual open day on the 24th of April for anyone that wants to find out a little bit more and ask some more questions of the course. In addition, for those that have been monitoring our website and also seeing the notifications, the BTS has jointly set up a series of short courses that last for 3 days with the University of Warwick. And the first one is in just a couple of days' time, which is on the Introduction to Tunnelling. We also have courses through the rest of the year on health and safety in tunnelling, tunnel design, and finite element analysis. So for further details and the booking link, please go to the BTS website for more details. The next slide is to announce the next BTS Young Members lecture. This is on Thursday, the 22nd of April, and it is on managing safety and tunnelling, and it is a joint meeting with BTSYM, TAIYM, and ICE London GNS, and it's a lunch and learn, so please join us for that one. Our next meeting is on Thursday, the 20th of May. This evening will be the BTS AGM, which will be followed by the May evening meeting, which is on CERN's High Luminosity Large Hadron Collider project. And that will be here on our YouTube channel. The next one is I wanted to just give a reminder that we will be holding the BTS 2020+1 conference from September the 30th to October the 1st. So please follow the links, as you can see on screen, to find out more information. Exhibition stands are open for general sale, and also to just find out more information. And we look forward to seeing you there. Next slide, please. The next one here is really to just give you a little bit more of a progress update on the book. I know I keep mentioning this each month, but it really is continuing to develop each month to keep you informed. So lots still going on, and please, as a reminder about what we're trying to pull together, and hopefully after tonight's bit of inspiration with the songs, sort of really see how all of this celebration of the 50th anniversary is all coming together. Next slide, please. We are, as I've mentioned before, we are still looking for some more volunteers to help with things like finding photos, project maps, timelines, identifying credits, to make sure that all this wonderful information that we've got and we want to be able to record is things that we're able to use. So if you are interested in helping and have some time available, please contact Ken Spivey, Sarah Langley, John Corcoran, Anita or Divic for further details of these roles. And once again, we really couldn't do this without our sponsors. So you can see there are a number of people that have sponsored already, but there is still plenty of space for your logo on the back cover. So if you are still interested in sponsoring, please get in touch. And then really just another reminder, and also to share with you the link so that you can go straight to that suite of songs that we've given you a little taster of this evening. And really just a thanks to the great work that Nancy has done here. And just as a reminder of all our social media tags and for any information about what we're doing at the moment. And then really a reminder, for any of you that haven't yet subscribed, please subscribe to our BTS YouTube channel and you will never miss a recording. Thank you very much for all your time this evening, and we look forward to seeing you at the next meeting.